Okay guys, we're going to be in your Agile Mind books on page 54. Here's number 4 for graphing another one of these exponential functions. We're going to start just like we did with our transformation form where we have our a times our base with our exponent minus our h plus k. And we can start with identifying our a, h, and k. Our a being the number multiplied in front, so our a is 1/2. Our h in here, this x minus 5, remember it uses that opposite sign, x minus 5. So our h is really a positive 5. And then we have that minus 4 over here. This is our k. Our k is going to be negative 4. So when we're describing those transformations, we're using that a is 1/2. Since a is between 0 and 1, that means we have a vertical compression. That's where it's going to get a little wider. Vertical compression. Our h is 5. H is our horizontal transformation, remember. So that means this one is going to go right 5. And our k being negative 4 means it's going to go down 4. So there's a few things we know already right here. Our domain of our parent function being this 4 to the x up here, is always going to be from negative infinity to positive infinity. And our range of our f of x function is always going to be from 0 to infinity. The domain and range are not going to change on our parent function. And on our parent function, also what's not going to change is our horizontal asymptote. It is always going to be at y equals 0. So it's going to be this line right here. We're not going to cross that when we're drawing our parent function. So I'm going to fill in my table with my x values so that we can find our f of x values. My x values, the ones we picked, those ones in the middle, it's our negative 2, negative 1, 0, 1, and 2. And we plug those in to our f of x function up here, our 4 to the x. So we can start in the middle here. It makes it simpler. 4 to the 0 is 1. 4 to the first is 4. And 4 to the second here, 4 squared, that's going to give us 16. When we look at those negatives, remember that that makes it our reciprocal. That flips it upside down. 4 to the negative 1, that's 1 over 4 to the first. 1/4. Our 4 to the negative 2, that's 1 over 4 squared, or 1 over 16. So now we have the points we need to graph our parent function. We got to be careful. I know these are real small. So negative 2 and 1/16, negative 1 and 1/4, 0, 1. Then we're going to have 1, 4, and 2, 16, way up here at 16. And this is our parent function, and it's going to come down and never cross that asymptote. So we've got all of that up there. To do our transformations to our g of x, to get to this g of x guy, we're going to do our transformations using our a, h, and k. I'm going to take my x, and I'm going to add h. So it's going to be negative 2 plus 5. Well, negative 2 plus 5 gives me positive 3. Negative 1 plus 5 is going to give me positive 4. 0 plus 5 is going to give me 5. 1 plus 5 gives me 6. And 2 plus 5 gives me 7. To do my y's, to get to my g of x, we're going to take our y values times a plus k. So we're going to go times that 1/2 plus negative 4. So 1/16 times 1/2. So it's getting even smaller. It's going to go to 1/32 minus 4. So we're going to have negative 3 and 31/32. So really close to negative 4. So then we're going to have our 1/4 times 1/2. That's going to give us 1/8 minus 4. So we're going to have negative 3 and 7/8. Then we're going to have our 1. We're going to take that y of 1 times 1/2, so we have 1/2 minus 4, negative 3.5. Now we're getting up into these bigger numbers. 4 times 1/2, we get 2 minus 4, negative 2. 16 times 1/2, and we get 8 minus 4, so we're going to be at positive 4. So now we're going to graph these points. So we have our positive 3, 3, and negative 3, really, really close to negative 4, way down here. We have 4, 3 and 7/8, and I actually did them on the wrong line, but that's okay, they're really, really close to each other. Then we have our 5, negative 3.5, again, super duper close. 6, negative 2. There we go, now we're starting to get that curve. And 7, 4. We can see here, and we can see where our asymptote is. I forgot to draw it in here, but our horizontal asymptote is going to be located at our y equals negative 4. So our line that we're never going to cross is here, located at our y equals k. It's always going to be at y equals k. So when I connect my dots without crossing my horizontal asymptote, we get a function that looks like this. And our domain of these exponential functions, it's going to be negative infinity to positive infinity. Our domain will never change, but our range is going to change. We have our range here that's going to start way down at negative 4. Negative 4 to infinity. Because the very lowest it's going to be is very, very close to negative 4. I'm not ever going to get there, which is why we have our parentheses, not our square bracket. But we're going to get really close to negative 4. And that's number 4.